Alrighty. So how this today's lecture is going to work is there are several rules that we're going to learn. So they're going to seem absurdly simple, okay? And the examples are going to seem very easy, and then you're going to get to your homework and you're going to go, wait, okay? Because the hard part is I'm going to give you again 3 or 4 formulas, and you're going to have to do some interpretation. What rule do I use when? Okay? And this is all about counting, but it's about counting large groups of numbers and combining, like we did with the bears and the handshakes and those things, all right? So this first rule, which is the fundamental counting rule, it says in the sequence of n events in which the first one has k possibilities and the second one has k2 and the third one has k3 and so forth, the total number of possibilities for the sequence will be k1 times k2 times k3 all the way up to kn. This is a very, very important rule. All right, again, it seems very simple. It's basically saying, let's say I had, I was trying to see how many outfits I could create, right? And I have 5 pairs of shoes, 3 pairs of pants, and 6 shirts. I would multiply 5 times 3 times 6 to get my total number of outfits that I could create. And that's essentially what that rule says. So you can write it in this word, you can use the example, however you need it, just write this rule down. Make sure that you have the formula there. So I'll give you a second to do that.
K1 times K2 times K3.
When it says in this case and needs to multiply, does that apply to any question that has an and in it? Or is it just in specific questions?
Yeah, well, when we get to the examples, it'll make more sense. Okay? So.
1 second, but to copy the rule.
Yeah, give me a second. Alright, can I go on?
K1. What was the example that you said before?
We're going to do an example in just a moment, then we'll talk about it. I just use clothes, like an outfit. Okay, so this example, again, when we're taking notes and stuff like this, everything that I have up here is also in the book, so you don't need to write down all the examples word for word. I would recommend working out some of the problems, but all the examples, if you refer back to them in the section of the book where the homework is, they'll be there. So, a coin is tossed and a die is rolled. Find the number of outcomes in the sequence of events. So how many possibilities do I have for tossing a coin?
1 over 2.
I have just how many possibilities?
2.
2. I have heads or tails. Okay, we're not dealing with probability yet. That's the next lesson. Okay, this is just possibilities.
This is 12.
Okay. Pardon?
Is the answer 12?
The answer is 12. Okay. Because we have 2 possibilities for a coin, 6 possibilities for the dice. We multiply them together, we get 12. Make sense? Seems pretty easy, yes?
Okay.
Alright. So a coin is tossed, so there's 2 possibilities. A die is rolled, there's 6. If I want to know how many possibilities I have total if I were to combine them, it would be 12. 2 times 6 is 12. Alright, going on. Okay, here's another example. Again, I would not write this all down. It takes way too much time and that's not worth your time.
Can you put this on EndNote?
Yes, and I'm actually gonna, because I'm recording this, I'm uploading this whole lecture. Okay, and you guys can fast forward through some of the times when it's pausing and that to go back to it. Alright? So, said a paint manufacturer wishes to manufacture several different paints. The categories include color, which we have red, blue, white, black, green, brown, and yellow. Type, latex and oil. Texture, flat, semi-gloss, and high gloss, and use outdoor and indoor. So if the paint manufacturer wanted to know how many different possible types of paints can I create using this, we're going to multiply. We have 7 colors. We have 2 types.
112.
Pardon?
112.
112?
I
I don't know if that's the answer or not.
10 times
I can't multiply in my head that fast. 2, okay. So we're gonna multiply them all together. So 6,
Like 84.
84, that sounds better.
Because I thought the texture was 4 instead of 3.
No, there's only 3. Okay, there you go. Alright, so there's 84 possibilities. Alright. So any questions about this rule? It's a fairly easy one. Okay? The problem is you don't want to mix this rule up with other ones. If all it's asking you is how many possibilities do I have total, always multiply. Okay? Always multiply. So. Okay, so this is an interesting problem. It says the digits 0, 1, 2, 3, and 4 are to be used in a 4-digit ID cards. How many different cards are possible if repetitions are permitted? Okay, so how many possibilities do we have for the first digit? Okay.
1 over
The first digit. 1 over 5.
1, 2, 3, 4, 5. Okay, 5 possibilities for the first one, because 0 is included. How many possibilities do I have for the second digit?
4.
No repetitions are repeated. Are permitted. 5. How many possibilities for the third one?
5.
How many possibilities for the fourth?
5.
5. We multiply them together.
20.
625.
Because it's 4, you have 4 numbers.
Pardon?
You have 4 numbers.
We have 4 numbers.
You have 5,
625.
but it's 5 actual digits.
Yes. So I have 5 possibilities for this one, 5 possibilities for that one, 5 for this one, and 5 for that one.
For only 4 of the 5?
Pardon?
You have 5 digits.
You only multiplied for the house
It's a
level.
4-digit ID.
It's a 4-digit.
Yeah, it's like if I have a pin number on my, so that would be one possibility.
Oh, it's a 4-digit.
It's a 4-digit number, but I have 5 possibilities for the digits. Make sense?
Yeah, but you have 5 possibilities for the digits overall. Why are you?
No, I have 5 possibilities for the first digit, 5 possibilities for the second one, 5 possibilities for the third, and 5 possibilities for the fourth. So how many different possible combinations do I have?
625.
So it's 625. So then multiply them all together.
Allah.
Does that make sense?
4 digits داخل ب 4 digits فعشان كده احكي عمليه كام زي 5
I remember it's around. It's all.
والرقم ممكن يبقى 0 او 1 او 2
Oh, I didn't see the 0. I thought it was just 1 to 0.
Okay, does that make sense now? Okay.
But like on the phone,
انا بعرف اشرح
like for example on an iPhone there are 10 digits, like 1 to 9 including 0.
Right.
So it's since it's a 4-digit code, so it's 5 to the power of 10. 4 to the power.
It would be 10.
10 to the
No,
power of
10 to the power of 4.
Yes.
10 to the power of 4.
عشان you still have the 4-digit
Cool. Yep. Okay, so let's take this same problem and let's talk about what happens if, and I accidentally put the answer on this one. Okay, so we already know the answer. What happens if repetitions are not allowed? So for my very first one, I have 5 possibilities, but now how many possibilities do I have for my
4
second?
because you deleted one of them.
4 because I used one. Okay. Then I have now 3 because I used another one, and 2 because I used another one. Okay. So the possibilities go down if repetitions are not allowed dramatically. Okay. So now I only have 120 possibilities. All right. Any questions there? We're about to move on to another
Where,
rule.
where does it say within the question itself that it doesn't include any repetition? Here you added something.
I did. I said so. It's the same problem. I said, what if repetitions are not permitted?
So you just cancelled out the part where it's
Yes.
So if it doesn't say repetitions are permitted, then it's not.
It will generally specify. Okay. So if it says, I would always assume the repetitions are allowed unless it says no. Okay. But here's the other thing: is that you've got to be able, and this is a really good question because you've got to be able to interpret a question. So if it says, I'm choosing, I want to choose groups of 5 people, okay? I'm gonna choose groups of 5 people, and I have 5 people to choose from. How many possibilities do I have? Would repetitions be allowed in that situation or not? No, because a person can't go to more than one place. So you have to be able to look at a problem and interpret it. Now, there's a question actually on your assignment today that asks, it's another 4-digit type code problem, right? And it just says, if I want to choose 4 different letters, right? And it doesn't specify whether repetitions are allowed or not. But if I want to choose 4 different letters, would I assume that I could repeat them or not? Yes, because by taking one letter out doesn't mean it disappears. But when I talk about people or things where I have a set amount, then I could repeat. So, and this is, like I said, the hardest part is interpreting the actual questions. Yeah.
This is like you should problems. Should like the keyword be like the total of possibilities?
So ask the question again. I didn't
Like,
understand.
because the last time we were studying probability, it was like the way it's like either way that can be the either
Right.
can be multiplication.
Really isn't. Are you asking if there's keywords?
Yeah.
There isn't. Sometimes they will be there, but they're not always going to be there.
Like when it says total of possibilities, it doesn't have to be multiplication.
Generally, it is, but not always. You see what I'm saying? Like sometimes there are other parts to the problem. So, and that's the problem with these ones, is it's the interpretation of the problem. And we're not today we're not dealing with probabilities. These are going to be whole numbers. Okay, you're not going to be dealing with fraction. Tomorrow, the lesson is about combining probabilities. And you will have a quiz over this. The first 6, there'll be 8 questions. The first 6 questions will come from this lesson. The other 2 will come from another lesson. Okay? So, another rule. Now, this is called a factorial formula. There is a button on your calculator that will do this for you, but I want you to know what it does, okay? So basically, if you have like a situation where we have a group, we have 5 people, and we want to know how many different ways we could order those people. All right? So we want to know how many possibilities we have. So if we start with, we have 5 people for the first position. How many people do we have for the second position?
5.
4. Okay, because we're talking about position. How many people do we have for the next position? 3. How many do we have for the next one?
2.
How many do we have for the last one?
1.
1. So that's what this rule does, is it takes something and it multiplies it down. 5 times 4 times 3 times 2 times 1. If it were 10, it would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Make sense?
No, sorry, can you say that again?
It's how many people how many things you have that you're trying to figure out how many possibilities you have. So if you have 10 things, it's 10 times 9 times 8 all the way down to 1. And it's multiplying
That's
down.
it.
Okay? Yeah, that's it. Okay, and it's called factorial. It uses an exclamation point. So if I would say 10 factorial, that is 10 times 9 times 8 times 1 all the way down.
What is the n open bracket
So,
n minus 1?
This is the formula. It's basically saying the first number times the number right beneath it, times the number right beneath it, all the way down to the left. The one.
And then 10 times 9 times 8. That is
Yes, so if n were 20, it would be 20 times 19 times 18 and so forth, okay? The special rule is 0 factorial, it always equals 1.
But what's with the minus? What is it?
Because it's saying like, if this, it's a formula, so it's saying if this is 10, what's 10 minus 1?
9.
9, what's 10 minus 2?
8.
8, and so forth. That's why formulas are general, they're broad, they always use variables and those kind of things to try to show, but you could apply that to anything, okay? There is a button on your calculator that will do this. Now, depending on your calculator will depend on what button you can use to find it. Now, a lot of times they're fairly simple if you have 5 factorial, 4 factorial, but if you end up with large numbers, which sometimes are undefined anyway because they're too big. Like I tried to do 120 factorial, the calculator wouldn't do it, okay? But there are things on your calculator that will do it. So, the Casios, I can't remember where they are. Let me look at it.
It's under mode 7.
Oh, right there. Okay, yeah. So you're gonna hit the second, or your shift key, and then x to the negative 1. So to do the factorial. The graphic calculator is a little more complicated.
Oh, when the explanation mark pops up, I just put any number?
Put in a number.
Shift.
I would make the number bigger than 40.
اكتب الرقم بعدها shift والزرار اللي تحت ال-
Now the graphing calculator, you're gonna hit the math key.
Yeah, no.
Okay. Now when you hit the math key, you're gonna see that it'll show up, it'll say math, and then I don't remember what the middle one is, and then there's something that says PRB. Okay, you need to hit PRB. You'll get very comfortable with this because you're gonna need that button for another part as well. Okay, that means probability. And then I think it's number 2.
This is not 3 things, it's what
Really three
Number
minutes.
4, okay? And then and different graphing calculators may have them in different places, but it's 4, and it just says exclamation point, okay? So that exclamation point stands for factorial. Alright, so did anybody else have calculator problems?
Then
Pardon?
what should we write so we get the expression?
So,
اكتب الرقم بدل
you mean for your graphing calculators?
Yeah, so do I just write like exclamation mark 10 and then
No, you do the number. So you would have to put 20, and then do this step, and then exclamation point. It'll-
No.
So you start with the number, so it's always the number first and then the exclamation.
Like for example, if I want to solve like the 10
Factorial?
factorial, it's 10 times 9 times 8. So basically, I put in 10. I add in like the exclamation factorial thing. I click and press enter. That's it.
That's it.
Says it now that I got 3.
the number is big. The number is like 18 digits.
So listen.
3,628,800.
دوس على اي رقم مع 10 عشان نعرف 10
لا بدوس
على
دوس على
Okay, so we're good on those calculators. Now, on your homework tonight, most of them you can use the calculator tricks. I will ask that on 8 problems, okay, you have like 20, I think 24 problems on your homework. But on 8 problems, I will ask that you at least write the formula down. So this is one that you could actually write the formula down for it without, as far as what if I wanted you to write the formula. Okay? So I will let you use the calculator tricks, but on 8 problems total, I want you to write, I want you to actually write the problem out. So.
Oh, quick question. So what's with the math minus?
Okay, this is on the graphing calculators. So if you need to get to this button, and there's actually 2 things in here. I don't remember the things, but you want the probability is where you want to find.
But for normal scientific calculators, just number shift and then.
Yeah. Okay. We're gonna skip that for a second. Okay, so this is where we would use a factorial. Okay, this is a 5 factorial, but we'll talk about the problem. It says, suppose a business owner has a choice of 5 locations in which to establish a net business. She decides to rank each location according to certain criteria, such as price of the store and parking facilities. How many different ways can she rank the 5 locations? Okay, so she has 5 locations. She wants to put them in order in some way. So it's 5 times 4 times 3 times 2 times 1, which is 120. It's the 5 factorial. Okay, so I think.
Yeah.
No, it's not. Is it 120?
Yes.
Yes. Okay. Okay. So she has 120 possible ways. Now this is also called a permutation. Okay. Now the thing about permutations that you need to understand is that order matters. This is going to be important. The order in which the objects are found matters. Okay. This is different from a combination where order does not matter. Okay. So anytime it has something that has to do with rankings or putting something in a certain order, where I have these 5 different locations, ranking it going 1, 2, 3, 4, 5 is different than 5, 6, or no, there's no 6. Sorry, 5, 4, 1, 2, 3. Okay, see, these are different rankings, yes? Okay, no, let's try this again. Let me. I want to rank my stores, right? Let's say I have stores A, B, C, D, and E. Okay? Alright, and I'm gonna rank this one 1, 2, 3, 4, 5. That's different than C, B, A, E, D, right? Because I want it, they're in a different order. Okay? So that's what this means, is that I can use the same values.
So what would the answer be?
The answer to this is 120.
No, not the other example. For example, then if we say
If order doesn't matter,
where order matters.
this is order matters.
Yes, but and then what? There's nothing. You're just putting down the formula. Yeah, you're filling in the formula.
Right. What I'm trying to do is to point out that that's why they're different. Okay? Because let's say I just wanted to, it's a little hard to talk about when I'm only talking about when I'm not choosing something out of it. But I have 5 possibilities, right? I can't compare this to the other example. Give me a few minutes to get to the other part, and then you'll see why they're different.
how to solve.
Pardon?
I didn't understand how to solve.
How to solve it? Okay. You're looking at how many possibilities do I have, okay? And I'm going to put the exclamation point there, all right, which is the factorial, which is on the calculator, and it will give me 120. If I don't have a calculator that can do that to me, this means I multiply all the way down. 5 times 4 times 3 times 2 times 1. That's all. Okay?
So it's just the same thing as multiplying the exclamation marks.
Yes. Okay. But what's going to happen now is that we're going to move into, it's still a permutation, but what happens if I say I have, and you don't have an answer to this yet, okay? This is where we're going to go to the next formula. I have 5 stores, and I want to rank, first, I want to give awards to the top 3 stores.
Well, we
Okay.
need numbers.
All right. So I have 5, and I don't know what my top 3 stores are. How many different possibilities do I have if I have 5 stores and I want to give awards to my top 3 stores, but I have a different price for first, second, and third?
6.
Okay. So, but I have 5 stores that I'm choosing from. So that's where the idea of the order matters. Okay. So this is easy because I'm just doing 5. All right. But if I have 5 stores and I want to choose 3 stores out of there, I want to see how many different possibilities I can put those 3 stores in order. That's a different formula. Do you see the difference?
No.
Okay, this one, I'm using all 5. If I'm using less than all 5, okay, I'm leaving stores out, then I have to use a different formula. Okay, because it's not 3 times 2 times 1, because I have 5 stores that I'm choosing from. So there's more possibilities than just that. Does that make sense?
Can you say it again?
Okay, so right now I have 5 stores that I'm choosing from, and I'm ranking them 1 through 5. Okay, but if I want to take from those 5 stores and I want to choose 3 of them and give them a first, a second, and a third price.
Okay, so it must be in order, right?
Pardon?
It's supposed to be in order? Or?
Yes, it's supposed to be in order. And how many different possibilities do I have in choosing those 3 stores? I haven't given you the formula yet, but I want you to notice that it's different because in this one I'm using all 5 stores. But if I'm trying to use less than that, I have to use a different formula.
Okay, and then when I'm using all the numbers, I use this formula.
Yes.
Plus the words, the second formula.
Okay, next one's carrot cups. Okay, so this is this right here is a P. Okay, stands for permutation. Okay, what I have to do is I have to say, and let's use this example of 5. Okay, if I have 5 stores that I'm choosing from, and I want to rank 3 of them. Okay, so 5P3. This is important because you have a calculator that will calculate it for you automatically. Okay, but I'm going to show you the formula. Again, part of the homework, I do want you to show formulas. Okay, I start with that 5 factorial on the top, and I divide it by, okay, I divide it by n minus r factorial. Okay, so this is 5 minus 3, what is that? 2 factorial. Okay. So this is the formula. You want to write that down. You need that. Okay, yes?
How should we write the 5P3 on the calculator?
How do I do that on a calculator?
Yeah.
I'm going to show you in just a second. Okay? But what I want you to know first is that if I don't have this button on my calculator, the 5P3, okay, I can do 5 factorial divided by 2 factorial. Okay? So however many objects I have total factorial divided by that minus how many I'm choosing. Okay? Because I'm trying to take out what I'm not using. Does that make sense?
There is a
Which
formula.
is the
Is what's the formula on the calculator?
Okay, give me just a second on that. Let me answer these questions
which
first.
is the 3, 4, and 5?
So I have 3 stores that I'm choosing, right? But I have 2 stores that are going to be left out completely.
Yeah.
So I divide by the 2 stores that are left out completely.
Where'd you get the 5? The 5 overall?
It's
The 5 is how many I had total.
And the 3 is the 3 that you choose, right?
3 is what I'm choosing. Yes. So what this says 5P3, and so it's 5 permutation 3. There's really not an easy word for that. Okay, on the calculator, if you have the Casios, there's actually, you can find it on there, it's one of the shift keys. It says NPR. I don't remember where it is.
times what?
Yes, it's right about the time steps.
Yeah.
Okay, and the graphing calculators, you know, are the,
And NPR.
yeah, it's in the same place as there.
Where,
Okay,
where
so,
was it? Where was it? You
it's
said
right above the time sign.
So after we put NPR, or do we put the number for?
Okay, so here's how you put it in a calculator, okay? I'm gonna have to type the number 5, then wherever my NPR is, now on the scientific calculators, they said it's above, on the Casios, it's above that time sign. In the graphing calculators, it's in the same screen as the exclamation point, okay? It's just one of the other options, all right? So you have to put the number 5 in first, then you find your NPR, and then you put a 3, and it will do it for you.
ايه ده what?
Same.
N 60.
Yeah, I don't have my calculator, so.
Wait, what do we do again?
Okay, so you put the number in, NPR, and then 3, and then we'll give you the answer. Okay? Depending on the type of calculator you have, it's going to be
ولا
different.
ولا تحدد
No, just put 5 first. Yeah, so 5, then that, then 3, and then
Ah, so 5 is for the total amount of beef from
how many hours?
I'm choosing. Ah,
Yes, passes. Yes.
I'm not choosing.
ثانية
And down. So do 5, do 5 first, then shift, and 3.
ايه الأس طيب؟
Makes sense? Alright. Okay, so this is super important where you're taking the idea of ranking or putting things in order. Okay? Because if all I was doing was just choosing 3 stores, the formula is different. Okay, but I'm putting 3 stores in order. I want a first, a second, and a third place. Alright?
Question, what is N and which one's wrong?
But after we get the F, okay. So 60 equals 5 exclamation point 2.
ايه؟
Yes, so if you were to do 5 exclamation point over 2 exclamation point, you would get the same answer.
No, let's have another question.
Okay.
What's going to be on N and what's going to be on?
N is always the total number that I have. Okay? R is the number that I'm looking for.
On this,
Yes.
if I skip the 5 and or 3 part and then do 5 exclamation mark over
It's the same thing,
exclamation
but it's
mark
two
on
different
calculator,
ways.
it's, okay, right?
Same exact thing. Yep.
الثانية أصعب.
Maybe. Yeah.
أيوة بس الثانية أصعب because it's saying it's giving me 3 to choose from. But you just put 5 and 3. It's the way I think. Because هنا بيقول لك you have 3 choices. So you تعمل 5 NPR 3 and that's it. بس الثانية you have to say 5 and then you take away the 3 and to say فاضل لك and then 5 over 2. So what do you do now?
Are we okay? Mohammed, you alright? Alright, let's do an example. Alright. So a television news director wishes to use 3 news stories in the evening. One will be a lead story, one will be a second story, and the last will be a closing story. If the director has a total of 8 stories to choose from, how many possible ways can the program be set up?
How many total?
So it's 8.
How many total?
There's 8 total, and he wants to choose 3.
So it's 8.
So it's 8P3. If I were doing it with the formula, it would be 8 exclamation point over,
356.
336.
what is it?
336.
336?
Ah, that's the other.
So, but if I were using the formula, it would be 8 factorial over 5 factorial. Make
Why
sense?
5?
Okay? Because, remember, I'm dividing out the ones I'm not using. Okay? So I'm using 3, so I divide out what I'm not using. Okay?
والله صعب.
لما ندخل بقى في شغل لأن بس probabilities
انت بص انت هتنجح الجزء الجاي انا هتصل كل حاجه بعدين.
Alright, can I show you something too? Okay, guys, really quick, I want to show you what this does. Okay? If I'm dividing this out, so it's 8 factorial, 8 times 7 times 6 times 5 times 3 times 2 times 1, right? And I'm dividing out what I'm not using. 5 times, oops, I forgot a 4. Times 4 times 3 times 2 times 1, right? These all cancel out. What am I left with?
8 times 7.
Times 6. Which some of that is just knowing that, right? You could know that I'm going to just multiply 8 times 7 times 6. That's the fundamental counting rule. So, Anyway, lots of different ways you can do this.
How many equations are left?
There's one more.
Wow.
كتبت ده؟
Okay, going on.
That was just
Shut up.
Alright, here we go. Here's another one. So I have 7 scientists, and I have a research project where I need a chairperson, an assistant chairperson, and this is covered up. I can't move that, sorry. And something else, I think a director, okay? If I have 3 people, or maybe no, let's do it with 2, okay? Because I can't see that other part. So if I have 7 scientists and I want a chairperson and an assistant chairperson, how many different ways can I do it? I can't move it because of the way that the screen is
There are
recording.
7 scientists and you want to.
Pardon?
Okay.
There are 7 scientists and I want to.
And I want 2, 7p, 2. Easy enough, yes? What's the answer? I don't want to calculate it.
42. 42.
42, and that makes sense sometimes. Okay, let's do the next formula. Okay, combinations. We're actually going to skip this part and then go straight here. Okay, so combinations are if order doesn't matter. When we were doing the handshakes, we had 14 people and we were choosing 2. It doesn't matter which one went first and which one went second, right? So when we were using the sports equipment, we had we were making selections of 3 different kinds, but it didn't matter what order they went. So that is where 1, 2, 3 is the same thing as 3, 2, 1, right? So the formula is a little different, okay? It's NCR, okay? So on your calculators, there is an NCR button, okay? So let's do, let's just make something up. Let's say I have 5C2. We'll just do something so I have
NCR
an example.
على scientific
Okay.
ينزل فوق الديفايد على الديفايد.
Yeah, the CR I think is, yeah, it's the divide, right?
So it's first I either use NCR or the
Yeah. So this is n exclamation point over n minus r exclamation point times r exclamation point. Okay, so this is a little different. This is 5 exclamation point over 3 exclamation point times 2 exclamation point.
Is the n still the total number and r the number of variables?
Yes. Yeah. So just thinking here, how many do you think is going to be bigger? Do you think NPR is going to be bigger or NCR generally?
Which one? PR.
Why?
Because because in this NCR you're dividing them both, like if you look at the exclamation part 1, you're dividing them both in the denominator, but the other one you're just dividing one.
Okay, that's a great answer. Okay, and that is one reason, but I would like to know intuitively, so not necessarily using the formula, but why would C be smaller than P?
C is larger. No, denominator is larger.
Pardon?
Denominator of C is larger than denominator.
Right, no, I don't know, let's not think about formula. Okay? Why would choosing permutations or things in order be bigger than choosing combinations? Why would that number be bigger?
Because the combination will be larger than the actual.
Permutations are actually larger than combinations. Why? Okay, so let's look at this for a second. Let's say I have we're gonna do it really easy. 3 numbers and I'm choosing 2 possibilities. Okay? So if I want combinations, if I have 3 numbers, 1, 2, 3, how many different ways can I choose 2 numbers out of 1, 2, and 3?
3.
Okay. 1, 2, 3. Does that make sense? Okay? Because order does not matter. Right? So 1 and 3 is the same thing as 3 and 1. But if order matters with permutations, is 1 and 3 and 1 different?
Yes.
Yes, so there would be more possibilities when order matters because I can use the same combinations more than once.
So
Because I'm putting them in
you
different
can
order.
say 1 and 2 and 2 and 1.
Pardon?
1 and 2 and 2 and 1.
Yes, would be different. So there would be more of them when you have to put them in order. Yes. Does that make sense? Why it's different? Because we have. Go
To
ahead.
have more combinations.
Yes, with permutations. Like when you use the word combination, I gotta. It's because we're using the word combination to say. I get what you're saying for the formula, but we have more possibilities because we're using the same numbers more than once.
But say like what like يعني طب خلاص the example
Let's do it.
Just wait.
Okay, so how many combinations of 4 objects are there taken 2 at a time. Okay, so we can use the, oops, that's 2.
6.
4C2, yep. Or we could do it 4 exclamation point over 2 exclamation point times 2 exclamation point. Alright.
So I have a question. Why do you multiply two times like only?
Okay, because in the combinations we have to take out the ones that occur more than once. Does that make sense? So this is taking out the ones that we don't use, and this is taking out the ones that occur more than once.
But what hints are there in the question that tells us between using the combination rule or the
In the permutation,
Yeah,
there is no,
permutation.
there's not keywords or anything, okay? You just have to be able to look at a problem and saying, okay, does order matter? Does it matter what order I take these objects in?
So if order doesn't matter, we use the combination.
Correct.
And if it does matter, like 1, 2, 3 is not the same as 3, 2, 1, we
Exactly.
use that permutation.
Permutation, yeah.
She said that the permutation has more combinations since it uses numbers more than ones.
Correct.
How?
How does that work? Well, what he said, because he said when we combinations themselves, okay, so NCR, okay, it has, we have this, like, we were use possibility 1 and 2, is the same thing as this one, right?
This is the point.
This combination. In permutation, 1 and 2 is different than 2 and 1. That's why there's more possibilities
In which one?
in permutations.
So the combination is less.
Yes. So this is less than this.
So when order doesn't matter, it's permutative.
This is the combination is 6 and the permutation is 12.
Yes. What'd you ask?
So when order doesn't matter, it's what?
It's combination.
Do you mean like when 1 can be 3 and 3 can be 1 in the places? That's
Right, so 1 and 3, and 3 and 1 are the same thing. That's why order doesn't matter.
no, but you said that if you could change it, then that would be permutation.
Right, if I can change it and it's different, it's a permutation.
الفكرة انت لو عملت combination لو permutation is twice the size.
What?
Permutation is twice the size. يعني 10 times 2 combination.
Alright, we're gonna do 2 more examples, okay? And then I'm gonna let you work on your own for a lot. I know I've thrown a lot of information at you. Okay, a bicycle shop owner has 12 mountain bikes in the showroom. If he wants to select 5 of them to display at a bicycle show, how many different ways can a group of 5 be selected? Okay? So if I have 12 bicycles, okay, now does the order of the bicycles matter? Like, if I have a red and a green and a black and a blue and a purple, is that different? So order does not matter, right? So I want to know how many different ways can I just choose 5 bicycles? So 12C5.
792.
700 what?
92.
792. Okay, again, just writing the formula really quick in case it's 12 factorial over 7 factorial times 5 factorial. Okay. Okay, the last example is a harder one.
Oh.
Okay. So it says, in a club there are 7 women and 5 men. A committee of 3 women and 2 men is to be chosen. How many different possibilities are there? Okay. So we have 2 different distinct groups here. Okay. We can't just lump them all together. Right?
You have to cut it in half. Like we solve the women first, then we solve the men, then we.
Pardon?
Can we do that?
And that's exactly what we're going to do. But when we're done, so let's do the women first. Okay. So I have 7C3 because again, order doesn't matter. I'm just choosing I'm selecting a group of people. Okay, and I'm not putting them in order.
35.
Okay. So this is 35, right? Okay.
5.
Now what about men?
هتطلع 120.
5C2, and there's 10. So now what am I going to do with these numbers?
Multiply.
Multiply. Very good. And I get 350.
Yay.
Alright. So if you notice, everything today is a multiplication. Okay. Alright, so we have 20 minutes left. I'm going to stop the recording. Wait, no, I need to get the next screen up and then I'll stop the recording. Okay. Not that one. This one. Okay, so 20 minutes left. I want you to work on your assignments here in class. So all problems can be used. Let me stop the recording.